Hey guys, welcome to today's video. In this video, we are going to solve one more Leetcode question, and the question number is 113 path sum 2, and it comes under medium. So we are going to solve this in today's video. In the previous video, we solved the path sum 1, which was an easy question. So we solved this. If you have not checked out that, please have a look. And now for the second one, the difficulty level has increased to medium. So let's understand this question, what is different than the previous one. So the question is saying, given the root of a binary tree and an integer target sum, return all root to leaf paths where sum of the node values in the path equals target sum. So in the previous video, in the previous problem, what it was saying, we need to just return whether root to leaf sums to target sum or not. So we just need to return the boolean. Okay, but in this problem, what we need to return, we need to return those values also from root to leaf, which is getting sum up to the target sum. So let's see this first example. So here the target sum is 22, and there are multiple branches from root to leaf which can like sum up to 22. So for example, like 5 plus 4 plus 11 plus 2, it's 22. And from another branch, 5 plus 8 plus 4 plus 5 is also 22. So there are two two values, or the two list of nodes. Okay, so we are returning list of list, and we are returning those values. So that is the difference. So in the previous problem, we need to return boolean. In this problem, we need to return the actual values. Okay, however, the algorithm remains the same. Only the thing is, we need to populate this result. Okay, so what I'm going to do, let's copy this so that we'll have a reference. Okay, let's copy this. So let's understand what we have done in the previous problem. So if we found, so we do a recursive call to our method, and we are keep on subtracting the value from the target sum. And once the target sum is 0, in this case, why it is not 0? Because we are here. Okay, we have not surpassed the leaf node, so that's why we root dot right should be null and the left should be null. So we are at leaf node, that's why we are doing an equal to the root dot value. Okay, if that's the case, we are returning it. Okay, oh, in this problem, I think we need a helper method since we need to populate this. So let's take the help of the helper method. Okay, so let me first create the result array, what we are going to result finally. Okay, it's a new array list. Okay, now we are going to take a list where we will add each value. Okay, so this will also be initialized to array list. Now we are going to take a helper function. Let's name it as same as path sum. We will overload it, and we are going to pass the root, the target sum, our result, and our list. Okay, once we populate the list in this helper method, we are going to return the result. Okay, so let's create the overloaded path sum method. So in this algorithm, we are going to use backtracking. Let's make it void. So let's make it as sum result and this list. Okay, so here also what we are going to write, if our root is equal to null, then we are simply going to return it. It's a void. We are simply going to return it. Now in this, we are going to subtract the sum. Okay, with root dot value. Okay, so we are subtracting the sum beforehand. Okay, so before call goes to the next value, to the next iteration, we are subtracting it. Okay, now we are going to add this list. Now we are going to add this value to the root. Now you'll ask, like, how we can blindly just add this value. What if it does not sum up to 0? Like what if we are blindly subtracting it and it will never sum up to 0? So what if, like, we go to 5, then 8, then 13? So what happens in that case? Yeah, we understand that in this binary tree we always have two branches, and there might be a chance, like, it when we choose a wrong branch and it does not leads to any result. So that's when the backtracking come into picture. So if that result does not satisfy, we are going to backtrack, and then we will move ahead with the feasible solution. So that's why we are using backtracking here. Okay, now we will check if root dot left is equal to null. So it means, just like, we are checking if we are at the leaf node. Root dot right equal to null. Okay, and sum equal to 0. So here, why we are writing sum equal to 0? Because we have subtracted beforehand. If you see in the previous one, we have not subtracted here. Okay, we are subtracting here. That's why we used target sum equal to root dot val. But in this, we are before only we are subtracting. Why we are subtracting? Because we have to add to the list. That's why we are subtracting here only. Otherwise, we have to check here also. If it's a sum, then here also we need to add to the list. So 2 times we would have to do that. So that's why, to keep the code clean, so we are subtracting over here, and we are checking if our sum becomes 0 or not. If our sum becomes 0, we are going to add this list to the result. Okay, we are going to add new of array list. Okay, and we are going to add to the result set. Now we are going to perform this recursively for the root dot left. Okay, sum, we don't have to subtract it since we are subtracting from here only. Okay, now result and list as it is. Okay, let's copy this and do it for right. And now if the result is not correct, so we need to backtrack. So how we will do the backtrack? List dot remove, we are going to remove the last inserted value. So list dot size -1. Okay, that's it. So let's try to run this. So our test cases got passed. Let's try to submit this. Okay, so it beats 100%. Okay, so hope you understood this question. So in the next video, we are going to solve path sum 3. Okay, see you in the next. Thank you.